Okay, let's talk about the next group, which is the P block. Again, remember the S and P blocks are your representative elements. So groups 1 and 2 are S blocks. Groups 13, 14, 15, 16, 17, and 18 are your P block. So group 13, that's your boron group. It's important to know that boron is a metalloid. Aluminum, gallium, thallium, and natrium, also known as niobium, are metals. They have 3 valence electrons, and they form a cation with a 3+ charge. Indium and thallium will act like transition metals with multiple oxidation states, meaning they can have different charges, and you'll have to be given those charges. Boron can also form a covalent compound. That is the exception to the octet rule. Let's talk about the carbon group. That is group 14. Remember, carbon is non-metal. Silicon and germanium are metalloids, 10 and letter metals. This is the group that, as much as we talk about families and groups being like elements that are similar in property, this is a group that is not true with. The only trend that really applies to the carbon group is that carbon is not representative of the other elements within the group. It's one of those groups that what holds them together is that they don't have any rules that really hold them together. They're all the little odd ducks. Here's some really important vocabulary when we're talking about elements and minerals. A mineral is an element or inorganic compound found in nature as solid crystals. An ore is a material in which a mineral can be removed at a reasonable cost. So you remove minerals from ore. And allotropes, this is really important. They're forms of an element in the same physical state, either solid, liquid, or gas, that have different structures and properties. I want you to think of carbon. You can think of like a carbon or a coal mine, that's carbon. Graphite from pencil, that's also carbon. And those clear diamonds, those are all carbon. That is all carbon in a solid, because due to pressure and the creation of some different structures and properties, they look different, but they're all basically carbon. Let's talk about group 15. This is your nitrogen group. They have 5 valence electrons. They gain 3 electrons to form a 3 negative anion. An anion means that they are gaining electrons. There are metals, nonmetals, and metalloids also in group 15. So they have a wide variety of properties. Nitrogen and phosphorus are your nonmetals. Bismuth is your metal. Arsenic and antimony is your metalloid. And bismuth is just very confused. It wants to lose 3 electrons to form a cation with a 3+ charge. Bismuth doesn't like to follow the rules. Let's talk about group 16 now. This is the oxygen group, and it has 6 valence electrons. It has 2 nonmetal members, oxygen and sulfur. It has the metalloids, selenium and tellurium. It has the metal polonium. But all the elements primarily pretend that they're non-metals. It will take 2 electrons to form a 2 negative anion, and it can also share electrons to form a stable electron configuration. Then we have group 17. This is the halogen group. And they're named specifically for their ability to form a compound with almost all metals. And any compound made within a halogen group is called a salt. That does not mean that you can eat all the salts the halogen group forms. Most salts are toxic and poisonous. But remember, the word halogen means salt former. They differ in their physical properties. Iodine is a solid that changes directly into a vapor. Chlorine is a gas at room temperature. Bromine is a liquid, but it evaporates easily, but yet all of their chemical behavior is incredibly similar. They're incredibly reactive. They are always found combined with other elements in nature. The astatine is a total exception in here. It's completely radioactive. We have no known uses for it. It's just there to be there. They have 7 valence electrons and they form an anion with a 1 negative charge. And then you have group 18. These are your noble gases, and they're literally called noble gases because they're crazy non-reactive. They actually all float, and they kind of are above everybody because they already have their 8 electrons, so they are happy. They're very stable. If you really annoy them by giving them lots of energy, they'll form an electron, they'll form a bond or a compound, but they kind of do it unwillingly. There's no known compounds of helium, neon, or argon. They have 8 valence electrons, and we don't talk about the noble gases in forms of creating ions or bonds in this class. When we're looking at the properties of the p block elements, we have to also look at their numbers in terms of electron configurations. And also, it's nice to see, I'm going to put them right next to them, their charges. So column 13, it's P1, and it's a 3+ cation. Column 14 is P2, and we really don't talk about the charge of column 14 because it tends to only create, in general, either very specific charges of cations, which you are told, or it forms covalent bonds, which don't have charges. Column 15, as a rule, is P3 and has a 3 negative charge. Column 16, as a rule, is P4 and has a 2 negative charge. Column 17 is P5 and it has a 1 negative charge. Column 18 is P6. P6 does not have a charge because it is incredibly non-reactive. They are already happy with their 8 valence electrons, except for helium, it has an S2. Helium is not in the P block, it's still in the S block. And that are the end of our P block elements and talking about the representative metals or representative elements.